In the quiet of a late summer morning in 1977, a machine was launched into the sky. It wasn't just metal, wires, and sensors, it was the sum of human curiosity. Voyager 1 was designed to survive where no machine had gone before. Today, it stands as the farthest-reaching object in the history of our species, hurtling through the cold, silent void. But as it drifts further from the warmth of our sun, we have to ask, what does it mean to be the first of our kind to leave home forever? The 1970s was a period of intense pressure. Astronomers realized a rare planetary alignment, Jupiter, Saturn, Uranus, and Neptune, that occurs only once every 176 years. If they missed this window, the mission would be impossible. The stakes were incredibly high. One failure meant the end of the dream. This was not just engineering, it was a desperate gamble against the laws of physics. Voyager 1 was a paradox. It carried computers with less processing power than a modern digital wristwatch. Yet, it was expected to survive the radiation belts of Jupiter, an environment that would fry most modern electronics in seconds. Engineers had to innovate under pressure, using rad-hardened components and redundant systems. This was the birth of our first interstellar explorer. As Voyager 1 pierced the dark, it approached Jupiter, a world of storms so massive they could swallow Earth twice over. This wasn't just a flyby, it was the moment our eyes opened to the true complexity of the solar system. Data flooded back, details of volcanic activity on Io, a moon that looked like a pizza scarred by fire and ice. We saw Europa, with its smooth, icy crust that hinted at a hidden ocean beneath. Voyager 1 acted as our eyes, turning blurry telescope images into crisp, terrifyingly beautiful realities. But the true danger was the radiation. NASA engineers held their breath as the probe grazed the edge of Jupiter's magnetic field. With a gravity-assisted slingshot, Voyager 1 was hurled toward Saturn. Here, the probe discovered the complexity of the rings, thousands of individual, dancing lanes of ice and dust. But the real prize was Titan. Wrapped in a thick, orange haze, this moon held the chemical ingredients for life. It was a masterclass in precision, proving humanity could reach out and touch the giants. For decades, we believed the solar system had a hard boundary. But Voyager 1 was about to show us the truth was far more strange. It wasn't a wall, it was a turbulent, invisible storm. The heliosphere is the bubble created by the solar wind, charged particles streaming from our sun. As Voyager 1 pushed outward, the instruments detected a dramatic shift. The solar wind slowed, then stopped. Cosmic rays from deep space began to slam into the probe with increasing force. It was the sound of a transition, a shift from the sun's home to the open ocean of the galaxy. In 2012, the world watched as data confirmed it, Voyager 1 had crossed the threshold. It was officially the first human-made object to enter interstellar space. But there was no celebration in the vacuum, only the relentless hum of the probe's thrusters. The emptiness here is absolute. It is a place where stars are just distant pinpricks of light. Voyager 1 is more than just a camera and sensors, it is a time capsule. On board, there is a gold-plated copper phonograph record. It contains sounds of nature, greetings in 55 languages, and music ranging from Bach to Chuck Berry. If an alien civilization ever finds it, this is what they will know of us. What do you think Voyager will find in the deep void? This silence is not an end, but a transformation, into a traveler of the stars forever. As we look up tonight, we know that one small piece of our history is out there, beyond the reach of our telescopes, carrying our voice into the infinite unknown. The journey of Voyager 1 is the journey of all of us.